Hello everyone, and today we're going to be going through the popular system design interview question of designing Google Docs, or more generally, a collaborative editing system. We're going to be going through the general framework that we usually do, just like the previous video, but this problem is definitely more challenging than designing Bitly. So we're not going to spend too much time on the basics. By the way, you can also read the full written version on System Design School, not this primer over here. This primer is also very useful. It's completely free if you want to check it out. Kind of teach you a lot of the background and stuff. But here down on the collaborative editing button, you can read the entire write-up. And before we get into this, I want to give a little bit of background, just set the stage. And warning, the screen is about to get very, very bright. And that's because we are opening up Google Docs. I'm not sure if there is a dark mode, but I'm sure you've used a document like this before. We create a document, we can set the title and set the permissions, and there's a version history baked in, there's comments, there's a lot of functionality going on here, and we're not concerned with all of it, of course. Can't really design everything in a 45-minute interview. We're mainly going to be focused on the real-time collaborative part of this, like having multiple users using the exact same document and making sure we can design our system so that we can have a pretty good solution for that. And there's going to be a lot of little issues and edge cases and stuff, and that's what we're mainly going to be working through. One thing you might be wondering is, how is the data shared? And specifically, I'm going to demo something to you. I'm going to make this shareable, and then I'm going to open this in an incognito tab. So here you can see that I've opened this window, and I can see somebody else is editing this. Navdeep Singh is editing this on my other account. And I'm going to open up now the Dev Tools really quickly. And I'm actually going to refresh this as well, so that we get all the requests. And here already you can see that there's this long running request. What is that? Well, it says bind because this is not a short-lived HTTP request. And I'll show you in a second what I mean by that. When I go back here to the other editor, I'm going to open up DevTools as well. I'm going to refresh the page so I get that initial long running request. And here I'm going to start typing hello world, doing a bunch of stuff. I'm going to even copy and paste the URL into this document, and heading back over to the other tab, I can see that those updates were indeed made to the document. But more importantly, look at this long running request. It's still going. What does it say? What happened during that long running request? Clicking it, we can see there's this stream of messages almost, and we can't interpret the exact format. We assume there's something going on under the hood with Google Docs. But when you look at the data of the messages, you can see, for example, here, that URL that I typed in, it's there now. That's not a coincidence. If I type in another long string, hello, and I just copy and paste that 10 times, and then I copy and paste that a few times, heading back over to the other tab, you can see now there's even more messages available, because every time we do something, data is exchanged back and forth. And here we can see that long hello, hello, hello. So this is just me kind of showing you a little demo, just dev tooling a little bit to get an idea of what's going on with Google Docs. And in case you're wondering, what protocol is this? It's not actually WebSockets like you would assume. I'm pretty sure what Google is doing is they're actually using Quick, Q-U-I-C. And that's because Google invented Quick. So yeah, and we won't go super in depth into Quick in this video. For our purposes, we are going to be sticking with WebSockets because functionally it does pretty much the same thing that we see is going on here. And I think it's worth going over a very brief 60-second demo of how WebSockets work, because they're going to be very important with the design of this video. So let's get into that really quickly. So here is some WebSocket boilerplate code that I pretty much just AI generated. So nothing fancy going on. This is JavaScript, by the way. And what it's doing is actually pretty simple. We're creating a WebSocket server using the WebSocket library of Node.js. Every time somebody connects to our WebSocket, we're going to check the URL search parameters, because what we're doing with this WebSockets is we are having multiple rooms. So not everybody is necessarily going to be in the same room. And in our design, the room is analogous to a Google document. A document is like a room in this case, because for the document that we saw, we don't want the messages or the edits that we send to the document to go to everybody who's using Google Docs. We only want it to be sent to the people using the same document. So the same document ID, for example. And so that's kind of what this is doing. It's creating rooms. It's using a hash map to do that. I think there are libraries that would do this automatically for you. But again, this is just a simple demo just to kind of show you functionally what's going on, what the functionality is, how we're going to be leveraging this in our design. It's using the room ID to check if a room already exists. If it doesn't, it will create a new hash set, which that hash set will contain all the people that are connected to that room. Every time there's a message, we're going to go through every client within that specific room and then send the data to all of those other clients. But we're going to skip one person. We're going to skip the person who sent that message. And we're doing that with this if statement over here, if you're curious. And of course, down here, when we disconnect, we are going to be removing that person from the room. If the room size reaches 0, we can delete the entire room. Pretty straightforward code. Now let's go ahead and run it in the terminal. I have 4 tabs set up. So on this first tab here, I am going to be running this code up above. So pretty simple, running on port 8080. Now I'm going to have one person connect to the room here with this code, WebSocket cat connect to localhost 8080. And here, query param I have is room 1. So I'm going to show you the functionality of these rooms. So one person is connected here. I can send a message, hello, but nothing's really happening. That message doesn't get sent back to itself, and it doesn't really go to anybody else because no one else is connected. Next tab over here, I'll connect this person to the same room, room 1, and now I'm going to type hello again from here, and we should expect it to reach the other guy. Yep, he found the hello, and I can go back, hi there, and the other person sees it as well. Lastly, I'm going to have another person connect to room 2, and you'll see that room 2 doesn't receive the same messages. So here, I'm going to say hello again, and the messages are only going to go back between these 2 people, not this one. So this one can send messages only within the same room, which is room 2. So there you go. Pretty quick demo. I'm sure most of you are already familiar with this, but I think it's worth going over the basics. Now I'm going to start off with step 1, gathering the requirements, and we're going to go pretty fast here. We'll start with the functional requirements. So the first one, of course, is that users should be able to create, read, update, and delete documents. So kind of like the CRUD stuff, then I'll abbreviate it with that. This is pretty straightforward, I think. Probably the hardest one is updating, and I guess even that could be split into 2 categories, like one updating the document metadata, things like the permissions, the file name, and stuff like that. But then there's the other part, which is actually editing the document itself, the text content of the document, and that is going to be the more important part. And so I'll actually make that a separate requirement. Let's say multiple users should be able to concurrently, that's kind of the key word here, edit the same doc. So pretty important. And I guess adding on to that, the updates should be visible in real time. So as somebody is using a document and somebody else updates it, they should be able to see that update in real time. Like it should be pushed directly to them. They shouldn't have to like click anything or perform any action, like refreshing the page, for example. And I guess another one, which is kind of included in these last 2, the cursor position. And this one is kind of important. And what I mean by this is like when you're editing the document, how earlier we could see like where each user is within the document. And that's pretty important because it can help avoid conflicts. So if we're both editing the same document, we don't want to be stepping over each other's toes. I don't want to be messing up something that you're working on. So if I see your cursor position and you're about to edit something, I'm probably going to avoid that. So that's kind of why this is important, but it can kind of fit into these other 2. There's a lot that's going to be out of scope within this, things like authentication, comments, permission, file sharing, offline access, and all that kind of stuff. So we're not going to be focusing on that. We're just going to be focusing on these. Now, getting into the non-functional requirements, things are going to get a bit more interesting because when we're thinking about non-functional requirements, we're kind of thinking about like bottlenecks and edge cases. Where are things going to break? Like, what do we care about? So for example, we might have millions of documents, right? I think that's pretty reasonable to assume that like the total user pool is going to be within the millions, possibly more than that. But is that really going to be the bottleneck? I mean, we can list it as a functional requirement, but it's not going to be super important here. We can safely assume that there's going to be a way for us to store these documents. Like storage is not going to be the issue. And most likely, it's not like every single document is going to be concurrently used. So I'll leave this one here, but it's not like super important to like dial this in and know exactly how many documents or even how many users. Let's assume that we have like in the millions of users, because it's not really going to affect our design too much. The more important requirement is how many users can concurrently use the same document at the same time. And we could make this really, really big. Like, what if it was 10,000? Well, first of all, think about it for a second. Like, try to be realistic. Even video games usually don't allow 10,000 concurrent players on the same server because things just get way too chaotic. If we had 10,000 people editing the exact same Google Doc, even if our system could handle that scale, it would kind of just be a mess. Everybody would just be messing up each other's changes and stuff. So let's set this to a smaller number. And this is actually the same as Google's Google Docs. So up to 100 concurrent users per document. So that's pretty reasonable, to be honest. And it's going to make our life a lot easier, and you'll see why. I think there are some other ones that kind of go without saying. Like, of course, we want the latency to be pretty low. So let's say the latency should be less than or equal to 200 milliseconds for those concurrent updates. So if somebody makes an update, I should be able to see that within 200 milliseconds in real time. And that's pretty important because if it's slower than that, then somebody might make a change and I might not see it for a bit, and then I might end up editing something and that messes up their change. So that can be a lot of like issues arising from the concurrency aspect of this. Of course, we want the documents to be durable, as in like they're persistently stored, but that kind of goes without saying. But in handling the concurrency stuff, sometimes there can be conflicts. And so we talked about how like having the cursor position can kind of help us avoid conflicts when it comes to like users actually editing the document. But imagine for a second, we have a document and that document is stored on the database. So here I have my document stored on the database. Now, what happens when a user is editing it, like we have two users, for example, let's make it simple. Well, one user is going to have their local copy of that document, and another user is going to have their own local copy of it. And now you might see where I'm going with this. When you have something and it's replicated, it's not replicated in the same sense like how we replicate database instances, but it's replicated on local machines. So if I make an update here, before it reaches the other guy might update their own data. That's going to lead to conflicts. We have to find a way to resolve those conflicts. So another requirement, and it might be kind of hard to get this out of your interviewer initially, but hopefully they'll mention it or maybe you'll bring it up. But we want documents to converge and specifically be consistent. So we should have some way of doing that. So I think we're in a pretty good spot for these requirements. We have a lot of context. So now we can move on to the next step, the API design / database design. There's not a lot of like entities here that are super important to us. So I'm not going to be doing too much of the database design. And even on the API design side, this is not going to be too interesting. So firstly, we'll have our standard endpoints for creating documents. So for example, something like this, posts / API / documents. We'll pass in like the document name and like title, stuff like that. We'll have a get endpoint probably to actually fetch the document contents with a little document ID URL parameter in there. Possibly have an endpoint to update the metadata of the document. But most importantly, we're going to be having an endpoint for WebSocket. So for that real-time concurrent user communication, every time a user makes an edit, that edit needs to be sent to every other user who's currently using that document. So we're going to be using WebSockets, like I mentioned, for that. So we might have some kind of endpoints like this, and it might end with collaborate. And you might be wondering, well, how can we have an HTTP API and then we also have a WebSocket API and it has like the same path as well? Well, think of it in terms of the API gateway. We could have multiple services. We could have a WebSocket service and then a separate HTTP-based service. And both of those could be behind the API gateway. So that's why the URLs kind of look consistent, but they're not the same service necessarily. I could dig a little bit deeper into some of like these high-level APIs, but there's really no need to. I think this stuff is pretty trivial. This is mainly what we're going to be focusing on. And when I say this, I don't mean like the actual endpoint URL. I mean like the functionality of this. And here we could have also included like a delete endpoint as well, but I don't think your interviewer is probably going to be interested in seeing you just write out all of these. So keep in mind that it's good to like stay on the same page as your interviewer. They might have different things that they want to focus on. Maybe they do want you to write out all of these, and that's okay. So now let's finally get into the fun part, drawing some boxes. And I'm starting here with a pretty simple template. We have here the client, and then we have the API gateway, pretty standard. And then here I have two services. You can probably guess what these are going to be. The first one is, let's say, the document service. It's going to be responsible for actually like creating the documents, deleting them, and handling that part. And then we're going to have down here the WebSocket service or the edit service, which is going to actually handle those real-time updates. And just in case you're wondering, yes, you can proxy a WebSocket service through an API gateway or a load balancer. It does work. Now, also on the right side here, I have my object storage and I have a database. Now, why would I have an object storage in the first place? Well, to actually store the documents themselves. And that kind of brings me to a point that we kind of glossed over when we were going over some of the non-functional requirements, but I think it's worth talking about them now, which is that how large are the documents going to be? We know there's going to be, let's say, millions of documents, but how large? Well, on average, I think most documents are pretty small, but we could have some pretty mega big documents. So let's say something like average is 100 kilobyte, average doc size is 100 kilobytes. I think that's pretty reasonable, but still we could have some massive documents. And so that's kind of part of the reason why we are doing object storage here. Since we're going to have some pretty big documents, probably better to store them here in a blob store rather than a relational database or a different kind of database that we might use. Now, if we're going to be serving the documents through an object store, probably fronting them with a CDN is going to be better. It's going to lower the latency. So this is pretty standard template here that we are following. And I'll just kind of put some dotted lines here to indicate that we are going through that CDN. If you're curious about knowing some like potential alternatives to WebSocket that we could have considered, because I kind of just jumped into it, because I think it's pretty obvious here that a WebSocket connection is going to be used for the real-time updates, but you can check out System Design School. The write-up has a few alternatives, including HTTP polling and server-side events. Now, heading up to the functional requirements to see what we're trying to do here, we want to be able to create and update documents. So here, I think that is pretty straightforward to handle because the document service is going to be responsible for that. So the document service could potentially create the document itself. It'll probably just be an empty document initially, but that same document service can update the metadata as well in our database. So let's say the database is going to be responsible for like actually storing the document IDs and the document names and all that stuff. And so now the journey from a user, let's say wanting to read a document. So you want to read a document. If the document is static, and it's not necessarily going to be static, obviously, and I am going to be covering that. So don't worry about that. I'm not trying to like gloss over it, but if the document was static, then we could easily go through the CDN and then the document will be fetched. And then that's only for reading the document itself. That's what the CDN is for, not updating the document or anything like that. But now we're kind of getting in to the part of what about actually updating the document, which I believe is definitely one of our requirements here. How do we handle the updating of documents? And it kind of goes along with the others as well. The updates should be real time. Well, that's where things are going to get a little bit hairy because now if I want to update the document, of course, I'm not going to go through the CDN. Now I'm going to go through the API gateway, hitting the document service and making an update. That's going to be pretty expensive. I'm not talking about updating the document title or something like that. That we could do easily just going through the database, but updating the entire blob, what does that mean? If I have like a really big document, a bunch of lines in it, and I make some changes, so let's say I change one of the lines a little bit. So this edit over here, we want to send to the object store. Well, object stores are not going to be able to handle that. They're not going to edit the file. We're going to have to create a brand new file with the edits applied. And if we're doing that, we're probably going to have to send the entire document over to create that new document. So even though we might have only edited one line in the document, it's going to be really expensive to update the document in the object store. I mean, it would be good in the sense that we would have some like version history. So that's pretty nice, but we don't really care about that in our current design. We just want the updates to be really, really quick. And that's not going to be the case if we have to send the entire document every single time. So how about we only send the actual edits? And if we're going to do that, how are we going to handle it? Because again, the object store is going to require us to basically write a brand new thing. Maybe we can somehow do that asynchronously, like the actual update of the document itself, and we can somehow use the database to actually store the edits and kind of use a dual approach, combining the object storage as well as the database layer. And that's what we're going to be doing. But I'm not done talking about actually updating the document because there's many things that we can do. So now let's step back away from even the object store and the database and think about updates in general. So we had approach 1, which was send the whole document, and we know that's not great. So the second approach we had is just send the actual edits, and that is much, much better. The edits are going to be relatively small, and every time an edit is sent to, let's say, the WebSocket service, and I probably should have had a second arrow going back here, because indeed the WebSocket service is going to be bidirectional. It's going to send data back and forth, but those edits will then be sent to all the other users, and then they can be applied locally to those users as well. So that's good, but the problem here, again, and I mentioned it towards the beginning, is what about the conflicts? That's the part that you have to worry about when you replicate data. And we're not replicating the data like on our database. We just have a single document, but we're replicating the data on the client's machine, and it can go out of sync. And we want the data to be consistent. Every user should see the same data. So consistency here is very important. It's not database consistency, it's like client consistency. And so doing this in a naive way, just sending edits in a naive way, is going to lead to issues. Let me illustrate the main issue that I'm talking about here. Suppose I have a string like this, hello exclamation mark. And we could consider this like an array. So I'm going to give each character an index. So imagine now I have 2 edits that come in. One is insert, let's say the character comma, and we do that at position 5. And let's say we insert another string, another user is inserting another string also at position 5, and the string that they insert is going to be, let's say, space and world. Well, watch what happens. And let's say like this edit happened roughly at the same time as this one, but this one was received by our server first. Well, then our array or our string, our document here is going to change. There's going to be now a comma inserted at position 5, and the other character is going to be moved to position 6. And then after that, let's say the next edit is applied. Well, if it was applied correctly, it would look something like this, space and then world. I know you can't really like see that fully, but it would look something like that, but it doesn't. Do you see the problem here? Now, even though this insert happened at position 5, well, now position 5 is different. We're going to basically insert this string here in between this and this. So here at position 5, that string is going to be placed. It's going to be space, and it's going to be world. And I'm not going to draw like all the indexes below, but you can see it kind of got messed up. This is the conflict. So what we were trying to do is, instead of sending the entire document, just send the edits. And while that would be faster, that is going to lead to conflicts. Sending the whole document as well would also lead to conflicts. So it's not like sending edits is worse than sending the entire document. It's just that this is an issue we do have to handle. So how do we deal with that? Well, in many ways, this is actually kind of like a data structures and algorithms problem. The concept is kind of simple. Think about this for a second. This example here at least, is pretty simple. I'll try to go through it. And by the way, the technique I'm going to be talking about right now is called operational transform. What it's going to do is it's going to take these edits, these transactions that are coming in, and it's going to transform them such that we end up with a consistent state. And more importantly, that these inserts and these edits actually make sense. So in this example, we see that we're inserting one character at position 5. And then after that, we see here, we inserted another string at position 5. Well, what operational transform is going to do is it's going to say, actually take this edit and transform it so that now it's actually going to be at position 6, because there was one character that was inserted. So we kind of have to offset this by 1. So this will be changed to 6. And now this will give us the intended result. Here, I would introduce the space and then the world after that. So this is just one very simple example of operational transform, but keep in mind that things can get really complicated. It's not trivial to code something like this up so that it'll handle every single edge case. I think that would be definitely elite code hard, probably even more than that, just because of the amount of code you would have to write to make sure you handle every case. So this is kind of the next step beyond just sending edits. The third way is to use operational transform. Now, another one that we could have talked about, and I didn't just because I don't want this video to be like 5 hours long, but you can read about it on System Design School within the write-up. It is last write wins, because most likely, I think most people probably haven't heard of operational transform unless they're like specifically studying this stuff. But I think you can still kind of reason about it. You can kind of reason that these edits could be transformed to make them a bit more consistent. But the other one that you can read about is last write wins. That is kind of a worse solution than operational transform, but it's more simple to reason about. So you can read about that one as well. But another one that we're not going to go over super in depth is something called CRDT for short, and it stands for conflict-free replicated data types. I might discuss that at the end if we have time, but for now, the approach we're going to be sticking with is going to be number 4, operational transform. So we can assume that as the edits come in, they are going to be transformed on the server, and they're actually also going to be transformed on the client. I'll mention that towards the end when we get to the deep dives. But at a high level, let's assume that now as we send in edits, they get sent to the WebSocket server, and before they are sent back and broadcasted to the rest of the people on the same document, they are going to potentially be transformed. I mean, not necessarily, we might not need to transform them, but if we do, we're going to transform them and then send them to all the other clients, and then every client is going to have the exact same state. And I guess I might as well mention this right now before we actually get to the deep dive, just because we're kind of talking about it right now anyway. But on the client side, why would we be doing operational transform on the client side? Well, think about this edge case. Let's say I have user A who did this edit and they did it locally. And let's say I have user B who did this edit and they did it locally. Now, we talked about the previous case where we perform this edit, and then for the second edit that came after it, before we can broadcast it back to everybody else, like before we can broadcast this edit to the orange guy, we have to transform it because we know that the original transaction was different. The original edit was different. So before we can broadcast it, to make it accurate and to make it consistent with what the original user actually intended and actually performed locally, we have to update it, and then we can send it to everybody else. So that's great. But now think about the perspective of this guy over here. He performed this edit, but not exactly this edit. He performed the original edit, so maybe this was a 5 before we operationally transformed it. So he did that edit locally. That's fine. But now this edit over here is going to be broadcasted to this guy because originally it happened first. But now we know that this was not the edit that was applied. If this was the edit that was applied, then we could use this one, but no, this is the wrong edit. So we're gonna have to, on the client side, it's not transform this edit because we already performed it. We're gonna transform the previous edit so that it can also be consistent with the other guy. So that's why we do operational transform here on the client side, and we also do it on the document side, not here, but I think over here in the WebSocket service. So that's the idea. And the other thing that's worth mentioning, and we're kind of getting into the deep dive section here, we're kind of blurring the line between high level and deep dive, but we probably do need some kind of ordering of these edits. Like we need to know that this edit actually happened first before this one. And what we can use is just the server. We can use the server as the source of truth because client times can be a little bit inconsistent. Like the client might make an edit, but that edit might not actually reach the server for like a few seconds, or maybe they're offline. So maybe it could be minutes. So that's why we're going to rely on the server to be the source of truth. As these guys come in, we will order them accordingly. So now I think we're ready to get into some of the deep dives and also to address a lot of these non-functional requirements, because that's where some of the bottlenecks are going to be made kind of obvious. And also, we haven't fully talked about how we are actually going to be doing the edits. Like we talked about how operational transform works, but if the entire document is still stored in the object store, and if every time we make an edit, we have to update that document here, things are not going to be great. So the approach that we're going to take, like I mentioned, is a hybrid approach, which is kind of going to give us the best of both worlds. We're going to have, every time there's an edit performed, we want our WebSocket service actually to send that edit to the database, and it's going to write that edit. So like, for example, like this first one here, insert a comma, and then maybe we'll get the next edit and then potentially transform it like we did. We saw originally this was a 5, but it gets transformed to 6. And then we take that transaction as well, and we are going to send it to the database. And we're also going to obviously broadcast it to everybody else. So now for a second, imagine we had an initial document, which let's say our initial document was just like hello. Then we have one person who opens up the document. Let's say they fetch that content from the object store. That's great. They make one edit here, and then maybe another person also opened up the document, and that other person made the second edit over here. Well, now those edits are going to be sent to the database, and they're also going to be sent back to each of the clients. So now let's say both of those two clients see the exact same state. They're going to see something like hello, comma, world. Now let's say a third user ends up connecting to the exact same document. Well, they're going to end up fetching the original document we had, which was just hello with the exclamation mark. And now also at the same time, they're going to, through the document service, they're going to look at the database, and somehow, we're going to fetch all of the edits that happened after that this object store does not have. So all of the new edits that were performed, in this case, just a couple of them. So the user is going to get this document, but they're also going to get all the most recent edits, and then those edits can be applied directly to the local copy of the document. So even though our object storage is kind of stale, it doesn't have the most recent document, that's okay, because it still has some version of the document, possibly like the older version, of course, but the newest edits are available, and we can get those, and then we can apply those. Now, you might be wondering, well, what about the object store? Like, when are we going to update it? When are we going to send these edits back here? Well, we probably don't want to do it super frequently because, like we talked about, it's going to be a high latency operation to do that. So we don't want to do it super frequently, and we probably don't want to do it while users are actually using a given document if there's already like a connection open. So how about this? When the number of connections for a given room, like within the WebSocket, and when we say room, we really just mean like the specific document. How about when the number of connections for that reaches 0, we can run some kind of job over here, like the WebSocket can trigger that job. So as soon as we get the 0 count here, maybe the WebSocket will send that somewhere, probably something like a message queue or like a message broker. And this is kind of optional, but I think it's still kind of nice to have. And it'll send a message saying, okay, for that given document, we want to perform something called compaction. We want to now take all of those new edits that we had, and we want to take them and we want to apply them to the file in the object storage. And then after we do that, we can kind of remove the edits from the database because the entire state now of the document is stored here. We don't need those edits anymore. Anytime a new user fetches the document, they can go directly here, which will take them through the CDN. So that'll be pretty fast. So now we get kind of the best of both worlds. You want to load up the entire document pretty quickly, go ahead and do that. You want to load up a document that's being edited currently, go ahead and do that. You'll get all the edits applied. You're editing a document in real time and you want to broadcast those edits to everybody else, go ahead and do that. Pretty easy to do, and operational transform will help us prevent any conflicts. So updating this a little bit, the message queue is going to then direct those messages to, let's say, a compaction worker. So this will be a pretty lightweight job, running to basically get those transactions, compact them. We know nobody's using them right now. It should be pretty quick, like under a second or two for each document. But maybe it'll take more, maybe it'll take a few seconds. That probably isn't a big deal though. So now our design is really coming together. We're not exclusively relying on object storage. We're only sending small edits, and then those small edits are going to be written to a database. What database should we choose for this though? It seems like what we really just care about is writing all the transactions, and eventually we'll read them, but the read is only going to happen once. We're really actually writing more than we're reading. So for that reason, we could probably just make this like a Cassandra database, which is a NoSQL database that's pretty optimized for heavy writes. Now, heading over to our functional requirements, or non-functional requirements rather, I think we're pretty good on the latency side. We can probably put a check mark there. We can handle the document size. That's pretty trivial in our case. That was mostly relevant for the latency part. And having the documents converge and be consistent, that's definitely handled as well. We kind of abstract that with operational transform. We didn't really get into all the details of that, which I'm pretty sure your interviewer wouldn't want you to anyway. And let's be honest, the vast majority of people don't know that off the top of their head. Now, the part where we have up to 100 concurrent users per document, that's kind of relevant to what I'm going to talk about. I think we can definitely handle this, but the issue is going to be about how many users we have and how many documents are going to be being edited concurrently. We could have possibly millions of documents being edited concurrently, not like the same document edited by more than 100 users, but separate documents. So how do we handle that? Like more specifically, how do we scale our services, like these two services here? I didn't really talk about it in the Bitly video, but typically scaling microservices like these that are not stateful, they don't maintain any important state. It's pretty trivial to scale them. You just add more instances of them, and our API gateway could load balance between those instances. So it's pretty trivial. That's why I don't even mention it. But scaling WebSockets is not so trivial in most cases. And when I say scale, pay attention to what I actually mean. I'm not saying that we need to have one WebSocket connection or one WebSocket room that has thousands and thousands of users. I'm not scaling a single document. I'm scaling all of them. I'm trying to say, basically, I just need more instances of this WebSocket service. And the problem with that is that these WebSocket services, they are stateful. So they do maintain state. Why is that an issue? Well, think about this for a second. The demo I did earlier with the WebSockets, if we have multiple instances of these, so I'll just kind of draw some boxes here. If we have 2 instances of this service, I need every user who's looking at a given document to be routed to the exact same instance. Because if it's a different instance, then we can't do that bidirectional communication, because we'll have one user sending edits to a different WebSocket instance, and then those edits can't be sent back because it's not the same connection as all the other clients. So all the clients on a given document have to be on the exact same machine. Well, this actually isn't that big of a deal. We can probably just use something like the document ID as some kind of key to tell us which WebSocket service we should go to, which instance, because then we can just route everybody on that document to the same instance. So for example, we could have something like this. This is obviously oversimplified, but we could say every document from 0 to 99 is going to hit this server, and then maybe everything from 100 to 199 is going to hit this server, and kind of et cetera, et cetera. And this might remind you of something, which is pretty much consistent hashing. So if one of these servers goes down, then we'd want to route everything to somebody else, and consistent hashing is basically the ideal way to do that. And I'm not going to go super in depth into what consistent hashing is, but if you want to learn more about it, you can definitely check out System Design School. I have plenty of resources covering that stuff for you guys. With that said, I think we pretty much covered everything we needed to. We actually have scaled everything within this design for the most part. I think there are plenty of other things that we could talk about if we really wanted to. Things like a rate limiting on the client side so that we don't send like 20 edits per second from the same user. Do some kind of debouncing or client-side batching. We could talk about versioning the documents using our object storage, and also possibly continuing to store the edits within the database. We talked about deleting those edits, but we don't necessarily have to delete them. We could tombstone them somehow, which is to say that we could mark them as deleted without actually deleting them. And in that case, we still preserve those edits so that we can display the history to a user. So that's pretty nice as well. But anyways, I think this video is probably going to end up being long enough. And I think we actually did go pretty in depth. I don't think there's a single video talking about Google Docs that goes as in depth as we did. We didn't get a chance to talk about conflict-free replicated data types, but those are pretty complicated, honestly, and probably overkill for a solution like this. And if you're curious, I think Google Docs actually did originally use operational transform. I think they might have switched to CRDT, but I think operational transform is very feasible for this. But anyways, I really hope you guys found this useful, and I'll see you pretty soon. Good luck in your interviews.